Okay, good morning, Year 11. We're going to try something a little bit different this week. So a video of your lesson that you would have had. We'll see how it goes. Obviously, any feedback, always most welcome. So to start with, it's a 4 questions based around the same question, as it were, which sort of links to the completing the square work that we did last week. Okay, so the answers are on the next slide. So have a pause of it, pause the video, and see how you get on. They are a range of questions. Yeah, let me know how you do. Okay, so answers. So there are all the answers. Obviously, the completed square form. So the turning point is 315. Remember, it's the opposite of the bit in the bracket, and the plus 15 is the y value. So the minimum value is 15. So basically, our graph is looking a bit like that, and that point there is 315. Sorry, that's 15, badly drawn. Okay, so this question down here, minimum turning point above x-axis, so no real root. So in other words, it's not crossing the x-axis, so it won't. You can't solve it basically. If you've tried to solve this, you'd probably get in a maths error somewhere along the line. Now this last one, or the last one, bottom left-hand corner, slightly different because it's 5 over that amount. That I think should say maximum value of a third, and I'll show you why. Hopefully this could all go badly wrong, but let's give it a go. So if I end show, we can discard that, and if I do that, I did draw it earlier. So actually that graph, 5 over 3x squared minus 18x plus 42, looks very much like that, and you can see that now it's a maximum because it's 5 over that amount, and it's a value of a third. Okay, so that's what the graph would look like if you were interested, but actually your answer is 5 over 15, so 15, but now it's obviously 5 over 15, so it gives you a third. Okay, so that's the starter. Now next, I also thought I'd have a quick recap of changing the subject to the formula, another topic from last week. So if you just pause your film, I will go over this one very soon. Okay, so hopefully you're back with us. We want to make t the subject to the formula. This was lifted straight off an exam paper. So let's expand the brackets. 2t plus 7. We're trying to make t the subject to the formula, so actually this is quite a nice straightforward one. So we need t's on one side, everything else on the other. So we've got 5t, take away 2t. We would have to add our 5g, and then to get t on its own, we can divide by 3. And actually I am just going to write it out. I was thinking I was going to actually do the division then, but I think I'll just write it out like that. So we've got t the subject of the formula. Just a recap of some of the work we were doing last week. Now on to a new topic, fairly new topic, direct and inverse proportion. Okay, whether we will get onto inverse today, well, we're not going to, we're doing direct today, but we are going to be solving problems and forming equations. 2 really important statements. Obviously we need to know the difference between direct and inverse or indirect, and the way I remember it is if we've got 2 variables said to be in direct proportion if the ratio of one to the other remains the same. So in other words, as one gets bigger, the other one gets bigger by the same multiple. Is probably a good way of thinking it. So if we had 2, 4, so say this was A, this was B, and then if A was 4, it would be 8. So it's always twice the size. So they're in the same ratio. Fairly simple example there. The symbol for proportion is like a fish on its side. Probably not drawn very well there, but that's the kind of symbol we're after. One's to look out for the indirect or the inverse proportion, because that's basically the opposite of what we've just had. As one increases, the other decreases. And the example that quite often comes up, I've put 4 men, takes 10 days to dig a hole. How long will it take 20 men? Well, it's not going to take them, how many, 5 times as long. It's actually going to be less time. So the best way of doing that is working out how long it takes one man to dig the hole, and then working back from that. But we'll look at some more indirect inverse proportion questions tomorrow or Wednesday. So that's what we're doing today. So to start with, what I would like to do, bear in mind on what I've just said, there's 4 situations there, so both with P's and Q's. I'd like to know which table Q and P are in proportion to each other. So have a little look, see if you can work out what's going on. As a bit of an extension, D, well, I just have a look at D. I'm not going to say anything else about that. So have a look at those, stop the video, and obviously come back to it when you are ready. So hopefully you've had a go and you've sort of worked through these. Now if we look at A to start with, so let's see if they're in proportion. Now if I do 3 divided by 1, well, 3 divided by 1 is 3. Then let's do 7 divided by 2, because if they're in proportion, they'd all have the same multiplier. Well, 7 divided by 2 is 3.5. So straight away you can see they are not going to be in proportion at all. They've all been multiplied by a different amount. So 1's been multiplied by 3, 2's been multiplied by 3.5, etc. So they are not in proportion. Let's do the same here. So, yes, no, they're not, are they? You can see they're not. 2, that's 5, that's 4, that's 3 2/3. So they're not in proportion either. Okay, well, that's not a great start. So let's have a look at the next one. Right, so 12 divided by 3. Well, 12 divided by 3 is 4. This looks a bit more promising. 16 divided by 4 is also 4. And actually, we hopefully all know that 40 divided by 10 is 4. So they are in proportion. And actually, Q is 4 times bigger than P. And you can see that working. Now, how you would actually write this, we are saying Q is proportional to P. You can write it the other way around because it works both ways. So Q is proportional to P. Now at the moment we've just got this proportion sign in here, but what you're quite often asked to do is to write down the formula that connects them. So what you need to do is we need an equal sign. So Q doesn't equal P, we can clearly see that. So what you've got then is I'm going to put a constant of proportionality in. Okay, I don't know why I've used a K, but anyway, we've got this amount that we're going to multiply by. So we pick a set of values. You're probably already looking at this and you can see exactly what it's going to be, but we put our values in. So 12 equals our multiplier, our constant of proportionality, and our value of P. So K is equal to 12 divided by 3. So our constant proportionality is 4. So going back to our formula, we can rewrite our formula now because we can say Q is equal to 4P. Obviously a very straightforward answer, and you would see that from the table. But that's the process you need to go through. Now, this one, did anyone actually see what was going on with this one? Okay, they haven't got a common multiple because that's times 6, that's times 8, that's times 12. Okay, but what we've actually got in this case, and you will get questions like that, is Q is proportional to the square of P, so P squared. Again, go through exactly the same process. Still have our constant of proportionality, except now when we put our values in, we put 18. So I'm going to use these ones here. 18 is equal to our multiplier times p squared, which is 9. So actually k is 18 divided by 9, which is 2. So our equation linking them, our formula, sorry, that's what we've been asked for, q is equal to 2p squared. And that should work for all of them. So if I take 4, for example, 4 squared, 16, times by 2, 32. It works. We can do exactly the same here. 6 squared, 36 times 2, 72. So you can see that it works. So we've got our formula, slightly different because that was p squared. And we'll be going on to a few more of those questions later. But we can get our formulas sorted. Now, I know you're keen all to have a go at this. So what I've got is a selection of questions, and I'd like the formula that's connecting P and Q and fill in the blanks. So see how you get on, please. I should state they are in proportion. Okay, they're all in direct proportion. Okay, so what we've got, they're in direct proportion. So if we look at A, we'll do A first. And we've got 7. Sorry, I really should write it out as Q is equal to KP. So Q, taking these values here, we've got 7 equals something. Sorry. Let's get rid of the 2, giving the game away. Times 2. Well, the K is going to be 3.5, 7 divided by 2. So for A, Q is equal to 3.5 times P, which means if P is 4, we've got 4 times 3.5. I hope this is all making sense. I do feel like I'm just talking to myself at the moment, but this must be 0. And to get from Q back to P, we've got to divide by 3.5, which gives us 6. Okay, so that's the first one done. Let's look at B now. B, we've got 4 is equal, so let's put a B so everyone can see what we're doing. 4 is equal to K3 or 3K. So K is equal to 4 divided by 3. Oh, 4 and 3. Oh dear, that's not very nice. Okay, and now because we've got Q, I just need to divide. Let's just write out the formula so we can clearly see it. So Q is equal to 4 over 3 of P. So to actually get, given I've got Q, I now need to divide by 4 over 3. So 16 divided by my previous answer gives me 12. And then 28 divided by 4 over 3 gives me 21. Just by rearranging this, really, I'm just substituting the Q values into here. Okay, hopefully you're getting these and it's making sense. So let's go for C now. We've got Q, K, 5 because I'm dealing with these ones here. So our value of K is 12 divided by 5. Oh, sorry, let's get it 12.5 divided by 5, which is 2.5. So our formula, and once you've actually got that, it's fairly straightforward. So if P is 10, that must be 25. If Q is 15, I'm just going to divide 15 by 2.5. Gives me 6, and then that must be 2.5. 1 times 2.5. Okay, and then the last one, it's going to be a fractional amount this time, so it's actually getting smaller. So we've got 2.8 is equal to k 3.5. So k is equal to 2.8 divided by 3.5, which is 0.8. Okay, so now we've got q is equal to 0.8 of p, just by putting the numbers in the formula. So we're basically just timesing by 0.8, another way of remembering it. So 4.5 times oopsie daisy, 4.5 times 0.8 is going to give us 3.6. They're still both getting bigger in the same way, so, or smaller in the same way. 5 times 0.8 is 4, and now I'm going to have to divide 16 by 0.8, which gives me 20. So I've completed those. Hopefully you can follow what I've done there, waffling away while I was working. You might have just fast forwarded and watched what I did. But anyway, that's fairly straightforward ones. I don't know why I put it on twice. Anyway, right. We're just going to look at one more example together, and then I'm going to give you a chance to get on with some work. So proportional to the square. Well, we kind of looked at one of these earlier. The flow rate of a square pipe is proportional to the square of its width. They've given us the starting point. This means, yep, okay, all very nice. So we can set up our equation with our constant of proportionality, pick a set of values. Doesn't matter, they all would work because we're told they're it's in proportion. So we've got 125 is equal to, but don't forget to square it, 20. For 25, so k is equal to 5. So actually our formula is that. Now the only thing you need to be careful of is if you're working backwards, you will have a situation where you have to do your square root. Okay, so if we say, for example, take this value here and we didn't have 40, we would have to do 8,000 divided by 5. So basically put the 8,000 in where the r is, but that's equal to w squared. And then, so 8,000 divided by 5, I really should better do that in my head, but I can't today. Gives us that, but that is w squared, so we need to square root that to get our w. Now you should have a plus and a minus there, but because we're actually dealing with a width, it's only going to be the positive, hence the 40. Okay, so your activity for today, 2 workouts. I've put the whole sheet on, but we'll be doing workout 2 and workout 4 probably tomorrow. So workout 1 and workout 3. Workout 1, very straightforward questions. Workout 3 brings in squares and cubes and cube roots. So make sure you have a go at both. Please, please, please only do the odd numbers. We don't need to do loads and loads of them, just need a bit of practice. Obviously pause the video now because the answers are on the next slide and I'm sure you wouldn't want to cheat. So have a go at those and then check the answers in a minute. Right, there's the answers. Hopefully you can read those. Obviously, any questions, any concerns, do let me know. And in fact, if you pause it, you might need to pause it because I'm going on now. The last activity I would like you to do today, if you could summarise your learning on direct proportion from this lesson, put it in Show My Homework. It's great to hear from you guys. Yeah, hope that's been a bit useful, a bit different. We'll see how it goes, see what the feedback says, and we will probably hopefully do one for indirect proportion. Anyway, take care and stay safe.